So in the last session, we have discussed the basics of reading from a disk. And in that, while concluding the session, the point that the problem that we highlighted in the scenario that has been seen, hardware operations. So the problem that was major in the last program that we have seen was like every time you are reading a byte from a disk, the disk operation will be performed. Now that if we use such programs, that will cause problem to HDD because the hardware read and write operations are very extensive, and so many number of read and write will get performed on the disk that ultimately the hardware will give up. By looking at the problem, the buffer concept was introduced with the file handling. So let me share my screen with you and we'll discuss. Is a screen visible to you people? Okay. So let's assume this is a file, a dot text editor, and you people are writing in this file, right? Okay, so the screen is visible to. Okay, fine. So now when this is a text file, and if I let's say type something, this is KITCOEK and Kolhapur, right? Now see there is a star mark in the untitled document. This is the file name, and it have a star mark, and the data that I've written is not saved. Now if I click on the close button, the prompt tells me that do you want to exit without saving, or you want to save, or you want to cancel the action that we have just clicked. But I have to select one of the option, right? And if I click on close without saving, whatever I've written, whatever I've typed here will be removed. This will not get saved on the disk. So this memory is called as a buffer, right? And so whatever I'm doing, whatever I'll type, uh, let me type some more lines. Department of Computer Science and Engineering. Now this information is also not written on the disk. This information will be written on the disk, right? So now I have to give the file name. Let me call it as demo file, and the extension is txt. I'll select the Java folder. I'll put the file in that. Now that star mark is gone, it means that the data is saved on the disk. Data is saved on the disk. So how many disk hardware operations are performed while saving the disk? So only one operation is performed and the entire data is stored on the disk. In the same way, if I want to open this, read this file, if I want to read this file, I can go and type a program name that can be used to open the file and gedit, and the file will be opened. Now this entire file will be fetched into the main memory and available for the reading purpose. Now this application here, which is a gedit application, is playing a role of a buffer in which we can manipulate the data. Unless and until we are not going to flush the data on the disk, the data won't get stored and the disk operation will be not performed. While reading also, only one disk operation has been done and it has tried to fetch the entire file from the disk and put it inside gedit. Put it inside gedit. So only one disk read or one disk write can be performed if we are using buffers. Now we will do exact application of a buffer in our previous program that we have seen in the last session. Let me close this file. Now I have two, three files in my directory called as a.txt. Then there is a demo file just we created and the first.java. If I show you the first.java program, you will find it's in a basic file input stream program that we have seen. And we know that this program is going to perform a very extensive disk operation. Every time it goes to the disk, it opens the disk, it reads the 1 byte and prints the data on the screen. So that is not good. And we have to use a buffer to so let's write a program which can optimize this disk read operation. And for that, we have to use buffer. So various buffers are available in Java. So let me create a new program called as second.java. Now this is going to be a new program in which I will just type down some of the buffers. So there is something called as buffered, whether you want to do an input depending on our buffered input stream or output, then buffered output stream. Then there is a data input or data output stream. So this is again another stream. So there is also a print writer stream which can deal with the characters. So variety of streams are available in Java. So in this session, we will particularly see the buffered stream, which is okay. In buffered also, you have buffered reader as well as buffered input kind of story, right? So when we are saying buffered input stream, if we are saying buffered input stream, then this stream is specifically designed to deal with the data in terms of bytes, like 1 byte at a time, kind of a story. And I am sure that from the last session, you are able to recall that the program that we created, this one, and when I use file input stream, this class is responsible for reading 1 byte of a data at a time. We are reading 1 byte of a data from a file. When it goes inside a while loop, each time it is reading from a disk, it causes a disk operation. But we are still reading a byte. So can we write a program which will read all the bytes from the file a.txt in one go, and it will be available for processing? So that's what we are writing. Now what we will do is, as this is a file input stream which is reading a byte from a file, we will use a buffer, or we will create a buffer which can understand bytes data. In the same way, the file reader, which is capable of handling character data, there is a class class available which can handle character buffered data. So today's discussion is going to focus on byte buffering the data which is read in terms of bytes, right? So let's quickly import java.io.star package, which is required for file handling, file and classes. I will call this file as public class second because my file name is also second.java. a very simple example in this. Let me type first .java. So I am in fact opening a .java file in my program. Now intc a blank thing while, and we have seen this program, right? So I will not repeat it. So what we want to do is we want to create a buffer in which the entire data will be read. So the wrapper buffered input stream behind is equal to new buffer input stream. Now this is also a class. The first class that we are interested in is a file input stream. The second class that we are interested in is a buffer input stream. Both are classes. The difference is the file input stream is capable to directly interact with the hard drive. It is capable of directly dealing with the hard drive of your computer. Whereas buffered input stream is a class which is a wrapper class. Wrapper class in the means buffered input stream is going to take object of file input stream. That means whatever operations buffered input stream is going to do, it's going to do it in the buffer. And to actually deal with the disk, the buffered input stream class needs the help from the file input stream class, which can deal with the disk. So in the simple terms, buffered input stream class is not going to interact with the disk. It is going to interact with the file input stream class, and the file input stream class in turn going to interact with the disk. So here, when I open up a blank notepad file, this file is not interacting with the disk right now. Even if I type anything here, this data, garbage data, is not going to disk. Here is a star mark. That data is not written on the disk. So, but when I click on save, that time a program to write this data on the disk get invoked, and the data is actually written on the disk. So in the same way, this editor area is representing a buffer. This edit area is representing a buffer. This buffer class is the area in which we are typing the data, we are reading the data from the disk, and this is the class which will actually read the data from the disk. Now, as buffered input stream is not able to deal directly with the disk, we will pass the object of the class which can deal with the disk. In our case, the class which is going to deal with the disk is file input stream, and its object is a file that we have created. So my buffered input stream class BIM new buffered input stream will accept file input stream object as an argument. Now what I've been achieved is buffered input stream class will tell the file input stream class to read the entire file in one go rather than triggering a file read operation every time you perform a read. Now you can use like intc is equal to bin.read. This call also works fine, as we have seen in the first.java. Let me open up the file first.java. Gedit first.java. Now, if I open up this file also, here you can see that there is a read class, right? Read class. Oh, sorry, not read class, read method, which is called against file input stream class. The same method can be utilized with buffered input stream also. But again, this read operation is not getting executed on a disk. This read operation is getting executed on a buffer, which is created above the file input stream class. But how many bytes it will read? It will still read only 1 byte. Let me open up a LibreOffice presentation. So let's say this is the file on the disk. So this is the file on the disk, and this is the main memory, right? And this is your program which is interacting with the file. So from the disk, data will be brought into the main memory and your program will interact with main memory. So this read and write is happening on the main memory and not on the disk. Only if you save the data, if you trigger a save command, that time only this data from the main memory will be sent to the disk for the storage. So when I mean buffer, indirectly I'm referring to this main memory. The data is available in your RAM and not on the disk. So when you perform this read operation, one may argue that, sir, in the first.java also we are reading 1 byte at a time, and in this program also right now we are reading 1 byte at a time. So what's the improvement? The main improvement is in the first.java, when we perform a read 1 byte read operation, that time the read actually goes directly from the disk to the program. So this first arrow indicates the communication between the file input string class and the disk drive. Whereas this second arrow, which is indicating the data flow from the disk to the RAM and from the RAM memory or the main memory to the program, is because of this buffered input string class. So even if I'm reading 1 byte at a time, and suppose there are 10 bytes in the file, this 10 bytes will be read from the main memory. And for each read operation, the program will not reach the hard drive. So hard drive will perform only one operation and all the 10 bytes will be fetched into the main memory, and the program will read 1 byte at a time from the main memory. So disk operations are avoided even if we use 1 byte at a time read operation. There are a variety of ways. Okay, let me complete this. Let me show you that we can use this and then we'll proceed. So C is equal to behind dot read, and then we'll just display the data on the screen. So I have to typecast, and here I'll say C. Second.java. Okay, buffered input string behind, and then behind dot read. Oh, there is not mistake with the behind. It is with spelling of read. So now here we are getting an exception because it's a cached exception, or checked, not a cached exception. It's a checked exception. Either I should use a try catch block or use the throws clause. I will not recommend using throws exception. I recommend using try catch block when you perform assignment program, right? So don't use throws exception clause. And Java second. Now you can see that the entire disk, entire the file has been read and has been displayed. So Java C second, and then Java second. So the file has been read from the disk. Now, but this is not a harmful program for your hard drive, because this time you are not reading every byte from the disk. You are reading every byte from a buffer. Now the second way of doing the same story is, instead of reading a 1 byte at a time, what you can do is you can read the entire file in one go, or you can decide how much data you want to read from a file. For that, let's say I want to read 55 bytes from a disk or from a file at a time. So what I can do is, let me create a byte array called as data, new data. And now I'll make this array of size, let's say 50. So I can read 50 bytes at a time, right? So the bin dot read, still the call is bin dot read. Now there is a difference. Difference is the first argument will be the array, byte array in which you want to read the data. The second argument is where to start reading the file. So I want to start the reading of the file at the 0th location, and how much data you want to read. So I want to read 50 bytes of data, right? So I will start from the 0th location and I'll read 50 bytes from the disk. Now the time to display what we have read from the file. So I can use simple println statement, and uh, as this data is in a binary format, see, data is a byte array, so that whatever we have written is in a binary format, zeros and ones. So we have to convert it into a string format. So new string will help us to convert the byte data representation into the string representation. So what I've done is system.out.println into bracket new string, and what do you want to convert? We want to convert the data array, because we have read the data into the data array, and now we are converting that byte data into string data. So let's see whether the output is getting displayed or not. Let me clear the screen one more time. Java C second.java. Cannot find some. Sorry, here again there is a mistake. So byte is the data type, and Java second. So here, by using 50 bytes, we have read only three locations, right? So what we can do is, let's say I'll read 200 bytes. I'll increase the size of my array. Again, I'll recompile the program and we will execute it. Okay, here I should have written 200. So 200 is my byte array. I also am reading 200 bytes from the disk. So recompiled, and Java second. Some more data has been read from the file or read from the buffer. Now it's a try and error, like how much data we really want to get from the disk file. So there is a function which is associated with the buffered input stream. The function is like, what I can do is I can use this integer variable c, and I can write is equal to bin buffered input streams object bin dot available, right? And then recompile. Now I've got data. What is this available? Let me print this value on the screen, system.out.println, and let me print this C on the screen. So compile Java second. So you can see that 363 is something. We will see what is the meaning of this 363. Whereas my array size is 200. So what if I replace this 200 value with 363? So let's do that. So let's do that. 363, and here also 363. Now like it's recompile and execute. Now here you can see that the entire file is getting displayed. So this available clause gives you how many bytes are available in the buffer, and using this style, by using a byte array, you can read all those bytes which are available in the buffer and display this entire buffer in one go, right? So this is how you can use it. So how we can verify this is, let me add some random data in the first.java file. So this is first.java file for reading bytes. from file. Now I've saved the file. Here you can see that there are total data available in the file is of 363 bytes. That must change. Now I'm not going to recompile the second, I'm going to just use it as it is. Now you can see that the data available in the file is 418, but we are not getting the lines, the remaining lines from the program, right? So let me go here. This is the hard coded value, which has resulted into that I'm not able to read the entire file. So what we have to do is this 363 must be replaced with how many bytes are available. How many bytes are available. Now this program can read any text file and display the contents on the screen. Doesn't matter what is the size of the file. So let me recompile now. Let's clear the screen and execute second. So here you can see that the entire file has been read and the number of bytes available in the file are 418. You can customize this program a bit more. For example, here you can type args and 1. With the small modification, let me compile the program again and say Java second a.txt 0 clear Java C second.java is the program Java second and a.txt. So now this program has been designed in such a style that you can pass any file name to the program and it will display the content of that file. So now instead of a.txt we can pass first.java and it will display the contents of first.java file. Instead of now we can, let's say, second, and the second.java file itself we want to display, and this is the code that we have used in second.java file. So this is how you can develop a program which can read any file from the disk and put its content on the screen. So there is a task. So I've showed you how to read a data from a file, right? Now in the similar steps, there is a class to write a data on the disk. So what we will do is we will develop a program which will copy the same file, whatever we are reading, the same data will be written on the disk. So that program can be done. So whenever you see file input stream, it also means that there is also a class called as file output stream, right? So let's try that. Let's try that. So I will delete this. Now writing one byte at a time to the disk. What we will do is we'll write entire file in one go on the disk. So I'll create a object of output string class. Let's call it as fout. New file output stream. Let's call this file as temp.txt. Of course, buffer output stream bout is equal to new buffer output stream, and fout will be the class that will be used. Now we want to write a data, but how much data we want to write? Let me show you. So I want to use bout dot write. What I want to write is I want to write the data array start from 0 and up to C, right? I will save the program. Now these are 3 lines which I'm using to write the buffer, whatever we have read from the input file to the output file called as temp.txt. Now let's try what happens. Let's see. So Java C second.java compile Java C second. So I haven't given the input file name, so I have to give input file name as first.java, right? So the file first.java has been read from the disk. The contents are displayed. Now let's see whether the contents are written on the disk or not. We have put some code which is expected to write the data on the disk. So let me type list command, which tells me whether temp.txt file is written or not. So temp.txt file is created on the disk. Here we can see that the file is available. Now if I do less temp.txt, the file is empty. So what happened? Where did the data go? Right. So quick pause here. Any guesses what has happened with the data? So I'm opening up a chat window. I need answers on chat window. What is your guess? What has happened with the data in this program? The data is not written on the temp.txt file, although the file has been created and there is no exception in the execution. What do you think? What has happened? Okay, voice is low. I just read this. Is my voice level good right now? Can you hear me? Am I audible? Yeah, okay. So what has happened is today I'm using a Debian system with me, and it has some, it's built in mic, microphone and all. Maybe because of that, the voice is sounding a bit low to you people. Data will be in buffer memory is the answer from Priyanka Talwar. Okay, fine. So Priyanka has given a correct answer. Even Aditya said that buffer. So I didn't get what is the meaning of buffer. Buffer only. But Priyanka Talwar's answer is very pinpointed and correct. Like data will be in the buffer. So that's why the data is not stored on the disk. Data remained inside a buffer. The buffer is buffered output stream. So this same effect. Let me open up this file again. Let me create a temporary file. So see, this data is not stored on the disk, but data is still present. Exactly. So this data is in the buffer memory or in the main memory. To be specific, in the RAM memory, random access memory, and it is not stored on the disk. So when I click on save, only if I click on save and provide a file name, then only this data gets saved on the disk. Otherwise, if I close this file without saving, then the data is lost, data is gone. The same thing has happened. Okay, so can you see, is my screen visible to you? First of all, is screen visible? Okay, great. Now, let's see what is the solution. So what I can do is I can say b out dot close, then b f out dot close. See, I haven't used this calls earlier. So I'm first time I'm using a close method against file output stream and buffered output stream. Although you can use this close method with the buffered input stream as well as with the file input stream. You can use that. Now, after adding only these two lines, b out dot close and f out dot close, let's see what is the effect. So Java C second dot Java second. Oh, sorry. Again, I have to provide a file name. Let's say first dot Java, and program has ended successfully. So let's clear the screen and let's say less temp.txt. Now you can see the data is available in the file temp.txt. So what happened is when we created a buffer, let me create a temp file, and when I click a close operation, here we are getting a window asking us whether we want to save the data or not. So in case of buffered output stream class, if we execute close function, then it will forcefully push the data on the disk. So data is saved on the disk. So adding only close call made it sure that your program is writing the data on the disk. So here, what is the trade-off? Now the next question is, using the close call, I can write the data on the disk. So what is still a problem in this program? What could be the optimization, or what a programmer or what application user will expect from the program, more from the program? Like you have a buffer, now the hardware operations are very low, and closing the file disk. Still, there is one trade-off. Can anybody tell me what is that trade-off? I'm expecting the answers in the chat box. Can anyone tell me what is still missing in this program? So everything is fine. You have created a program which reads the file, which saves the data upon closing the file. So still, one may not be happy. The end user may not be happy. So can anyone tell me what could be the reason why end user may not be happy? Harshit Joshi is saying save. Can you tell me, Harshit Joshi, what do you really want to say by only sir? If out मध्ये save nahi hot. If out मध्ये save nahi hot. Okay, I close this just to make sure that all the handles are getting closed, right? All the so that I really this is not the answer that I am expecting. Still, nice try by Aditya. Can anyone tell me what is missing in this program? What a end user may expect from the program? Okay, so every time we have to close. Yeah, this is the answer that I was looking for. Shardul, the answer is very right. So what is the trade-off in this program is, if you want to save the data, you have to execute call close. If you close the file and if you really want to use it again, then all you have to go back to the first step of using a buffered input stream, creating a new object, then opening the fin object, then reading the entire data back into the buffer, and then working on that buffer. Again, you want to save the data, again close the data, close the buffer, and this step will get repeated. So this is not a correct, or this is not a valid option to save the data on the disk. Although this is working as a flush or forceful save operation, the programmer may not intend to save the file every time he wants to save, close the file. So that is what is not expected by the programmer as well as not by the user. So there is a call called as flush. Let me show you that. Now what I'll do is I will remove this close call, right? And let's recompile the program again. This time let me open a.txt file. Okay, so my temp file. Okay, so the data is flushed on the disk. So data is flushed on the disk. So I hope you got the data, got this program of reading from a disk and writing in a file on the disk. So this is exactly a copy program. Now what you can do is we can make a small change in this. Let me make a small change in this program. And the changes, instead of using a temp.txt, I will say here this into bracket 1, and now let me compile the program again. Java C second.java. Is my voice audible to you? Am I audible? Yes, okay, fine. So now let's execute Java second, and the input file I want to show, I want to copy, let's say first.java file. This is the file that I want to copy, and I want to copy it into the file called as, let's say, java underscore backup dot txt. I'll hit enter. So the entire program has been first displayed. First.java file, contents of the file has been displayed. Also, if I check out the contents of java underscore backup.txt file, the data is also copied. So this is a perfect program that we have developed. It is the perfect program to copy the one file into the other file. And if I just put a comment on this line, system.out.println, the data will not come on the screen. Instead of that, what we can do is, after performing the close operation here, we can simply put a message like the file and then args, let's say 0 plus is copied in plus args 1, right? So if I execute this, okay, I have to recompile java c, and now instead of getting an entire message on the screen, first.java, and let's say temp2.txt. Okay, I guess something is wrong. Have I overwritten the first.txt java file? No. No. I have made a spelling mistake in the program itself. So the output is getting displayed. One more data is getting displayed, which is the size of the entire file, which I've printed here. So I have to put a comment on that also. Let's go back. Have I saved? And then compile. Sorry, Java C second.java and run this. The file PID okay again. So this program is going to copy the first.java into the temp2.txt. Now if I open up the contents of temp2.txt, you can see the contents of temp2.txt are available. So what we have done is we have developed a command prompt utility using which we can copy the data from one file to the other file. For example, Java second. Instead of this second, you can call this class as my file copy program, and you can use this program to copy the data from one file to the other file. So this is a simple file operation. Now the real task is, like, your program has used the byte and one byte to represent one character. What if your program use 2 bytes to represent one character? In that case, this program is not going to work while performing a copy operation. For example, in the gedit itself, if I create one more file, let's say this is copy of the UTF-8 encoding. Fine. When I click on save, at the bottom part here, you can see that there is a UTF-8 encoding. There is also ISO 8859 encoding, and there is also UTF-16 encoding. So if I use this UTF-16 encoding, and if I click on save, what I have done is, in the file I am saying this is copy of UTF-8 encoding, but while actually storing the file on the disk by using this save option, while actually storing the file, I have to use save as option to save, show you the here option. I am using UTF-16 encoding. What is the meaning of UTF-16 encoding? In this UTF-16 encoding, you will be using 16 bits to store one character. In the UTF-8, you will be using 8 bits to store one character. Now, if I'm using UTF-16 encoding to write the data, now the file is already been saved. I'll click on cancel. So this file has used UTF-16 encoding while writing the data on the disk. What if you use UTF-8 encoding while reading the data from the disk? there must be some problem. There must be some problem, must be some issue, right? So now this different kind of encoding mechanism your program must be able to handle. For that, we have used like if we want to write a UTF coding on this disk, we have to go with the data input stream class. Data input stream class. Also, data input stream class have a variety of methods. One particular method that we are interested in is called as a write UTF and read UTF. So data input stream and also data output stream. Data input stream, there is also a data output stream class. Let me go to the program. Where is it? Here. So parallel class to the buffered input stream is data input stream din. So I'll put a semicolon here and I'll put a comment on this, right? Also, this is for reading, and in the similar ground for writing, parallel to the buffered output stream, there is one more class called as data output stream. I will call it as dout. Now this data input stream class have a method. This data input stream class have a method called as din dot read UTF. Now this method is specifically designed to read UTF encoding from the disk file or from the input or from the source for which the data input stream object has been created. On the similar basis, the data output stream class have a method called as dout.write UTF. Now this method is specifically been designed to write the data in Unicode text format. So see, there is a difference. The program that we have used right now, one is for the reading, which is here. This is the read method. It is reading the byte by byte information from the file, and while writing also we have written the entire file on the byte by byte format. So the byte array has been written on the disk. The data output stream class is not dealing with the byte or how many bytes you want to write or how many bytes you want to read. It is dealing with the Unicode text format. Now see, like this file has used UTF-16 encoding, and if you use a program which uses UTF-8 encoding for reading the data, then that will create a problem, right? That is going 100% going to create a problem because you will be reading a misinterpreted data from the disk. So what can be done is, let me show you the example. Here, let me use untitled document and let's say demo.txt file as an output. Okay, one file has been copied. Let me use less demo.txt. Can you see the Chinese characters? Not exactly Chinese characters, but can you see some garbage information that your program is not able to deal with? Okay, let me go to the chat window. Is my voice is audible or I'm been disconnected? Hello? Audible, great. So I hope you can see the garbage data which has come on the screen. Why this happened is because see, this file I saved with the Unicode 16, UTF-16 encoding. Even if I am saying UTF-8, I have showed you earlier that I am using UTF-16 encoding while writing this data on the disk. And I've made clear that the program that I'm using here is making use of byte by byte reading from the disk. So when you read one byte at a time and you're using 2 bytes to write this T on the screen, or you are using 2 bytes to write this H on the screen, on the disk, not on the screen, on the disk. So you have written a different encoding while writing the data, and while reading the data again you are using a different encoding. So that of course creates a problem. Now if I open this untitled file, up to what file I used? I use a file name as demo something, right? let me demo.txt. Let's go and open this demo.txt. So where it is, demo.txt file. Now here demo.txt is been read in the very correct format. So the both files have a correct information. So how come the command prompt is not able to handle this? How come command prompt is showing some different error, different message, right? So what has happened is the command prompt is trying to display the information in a 1 byte format, and the gedit is capable to handle different encoding schemes. So gedit have a support for variety of encoding schemes. For example, gedit can support UTF-8 encoding, ISO 8859 encoding, UTF-16 encoding, or you can add more encoding support by clicking on this add or remove button. So my gedit is capable of handling UTF-8 encoding. So the demo.txt file opened in a gedit shows the exact data that is expected. But the program that we have developed, which is second.java, is not capable of handling UTF-8 encode, UTF-16 encoding. So the garbage information came on the screen. So that what happened. So I hope you got the session. So there is one quick poll, and we will end the session. And in the next session, we will see South Korean, Japanese, Chinese symbols appearing on the screen, right? So before ending the session, let me take one quick poll. Before taking a poll, anyone have a doubt? Post your questions in the chat box. If anyone have a doubt, post your question in the chat box. Okay, fine. So I'll take that as no question. So let's go and take a poll, quick poll. So let me my sharing, screen sharing, and let me go to the poll. Okay, one more problem that I am not able to have a poll in Debian. I haven't installed a plugin required for conducting a poll. So fine, the question that I was interested in asking is, if I use 16 bits of encoding while writing, if I use 16 bits of encoding while writing, and if I use file input stream class for reading the data, this class, file input stream, plain file input stream class for reading the data and displaying it on the screen, whereas my writing encoding is of UTF-16 encoding, what will happen? The data will be read in the correct format, or we will get some garbage data on the screen. So you can post your answers in chat box. Okay, I'll repeat the question. Question is, I will use this UTF-16 encoding while writing the data. I will use UTF-16 encoding. So my data on the disk have UTF-16 encoding. While reading from the disk, I will use this plain file input stream class. I will not use any buffer. I will not use any data, nothing. A plain file input stream class. There is nothing in the program. A plain file input stream class will be used like first.java. So this program can be used file input stream, a plain class, and I'll be displaying this program, this output on the screen. So if I'm using a 16-bit encoding while writing the data, and if I use plain file input stream class to read the data from the disk, whether the data will be read in a correct manner, or you will get errors, or you will get some garbage symbols on screen. What do you think? Quick answers in chat box. Garbage is one answer. Garbage symbol. So okay, so most of the people have given the answer as garbage data. So what we will do is we'll keep this question open, and next session will start around the same question, and definitely we will see how to deal with different encoding mechanisms and why Java says that Java. Okay, one more point that I have to make here is Java supports different encoding mechanisms. So Java can handle altogether different UTF standards. Even our latest Java environment can handle very latest UTF encoding, which can support up to 16 bits of a single character where up to 20 bits of single character. So that encoding mechanism is available with latest Java version, right? So Java mechanism is able to handle a different encoding scheme. So next session will start with why Java supports different encoding mechanisms and UTF encoding schemes. And also we will see what will happen in this case. Like we will create a program which writes the data in UTF-16 format, and we will use a plain file input stream class to read from the file. Then we will create a file which creates the data with some other UTF standard. Again, I'll use the same program of file input stream to read that data, and we'll see the results, and then we'll talk about why the results are getting so fine. So till that time, we can I think we can leave the session. And before coming to the next session, I strongly recommend try this. Create a UTF-16 file, create a same plain program for file input stream, and try to use that file input stream program to read from the disk. Okay, so I declare end of the session here. You can leave. See you in the next session.